then it will have to go through, so that's called capacitation, and then it will increase its motility as well before it fertilizes. Okay. 3 corpus, and then there's a gland penis, and then the prepuce. Okay. Here is the corpus spongiosum, and then there is called corpus cavernosum. Okay, 2 corpus cavernosum. Now these during erection, the blood will fill the corpus cavernosum, hence the name. It's got caverns in there. Okay, and then here it is. Okay, cavernosum, it's filled, and then the spongiosum is filled. That's why, and then it will block off the blood from returning. So that's how the erection is maintained. Yeah. One more thing to talk about this. So in the lab, they might ask you what this section. This is the shaft, and right here before the glans penis. Okay, this is right here in the beginning. Is called the prepuce, and here's the glans penis. So during arousal, okay, nitric oxide is released, causing vasodilation, and then blood will fill there, and then it will be compressed so the blood doesn't leave, and then you will have a maintained erection. How does all of this production and development get controlled? Hormones secreted by the hypothalamus and pituitary and the testes control the male reproductive function. Remember, there's testosterone and androgen. It's produced by Leydig cells. Remember this term, Leydig cells. Okay, and then function promotes spermatogenesis. So Leydig cells, okay, will produce testosterone, and then it will help with the Sertoli cells to make sperm. Okay, so both of those cells are important to remember. Levels are controlled by negative feedback, begins at puberty, and lasts greater than 65. So here it is, the hypothalamus and the pituitary gland. So gonadotropin releasing hormone causes the follicle stimulating hormone and luteinizing hormone to be released. We've seen these before. FSH binds to Sertoli cells. Okay, Sertoli cells make sperm. Okay, and produce inhibiting, which stop FSH from overproduction. LH will then bind to Leydig cells to increase testosterone. Okay, so Sertoli cells will start the spermatogenesis. That's FSH, and LH will bind to Leydig cells. Okay, just remember L and L. Okay, and this will increase testosterone production. Once testosterone production is increased, then the FSH will start making sperm. Controlled by negative feedback. If it's too low, then you stimulate this. If it's too high, then it stops. Okay, as simple as that. Okay, so that is the male reproductive organ. Now we're going to go into the female reproductive organs. So the female reproductive organ is similar to the male reproductive organ, but it has an additional task. Okay, additional task of developing the fetus, and the organ is mainly internal. Okay, the internal being instead of testes, okay, it's got ovaries. Okay, on the inside. So the external genitalia. Okay, we have the prepuce here, and the glands. Okay, the clitoris, if you want to call it that. Okay, there's labia major, labia minor, and then there is the urethral opening and the vaginal opening, and then there's the anus there. Okay, so all this collectively is called the vulva. Okay, and vagina is the entrance, and there is connected to the uterus cervix at the fornix. Fornix is at the end of the vagina. So here's your vagina. It goes all the way in, and here, before it goes into the uterus, that is called the fornix. Okay, just you can just imagine that. Okay, so it produces. So it's got rugae. Again, rugae we saw it in the stomach. We saw it in the in some part of the body that will expand. Okay, so it could expand, and it's populated by lactobacillus, which that's why it is acidic, and is to protect. Okay, that's why when the sperm goes in, it needs to a lot of them will automatically dies from the acidic environment. So ovaries are the primary organs. It's held up by 3 ligaments. We're gonna look at them. I have another picture to show you. So the broad ligaments is, it's all around here. Okay, here, and it's just broad. Just think about the broad term, so it's everywhere. Okay, and there is a ovarian ligament, which it's right in front of the ovary, and there is another suspensory ligament, which is around there to hold the ovary in place. It holds the ovary in place. Okay, and here is the we're gonna look into all those, the fimbriae and all that. Okay, here's what an actual ovary looks like. Okay, so the ovary it's about the size of an almond, and it's got an outer covering, and then the inside covering, tunica albuginea. We've seen that in the male reproductive organ as well, and in the cortex, it's got something called the stroma. Stroma. It's a connective tissue, pretty much like a framework. Okay, and then the medullary, which is the inside, got lymph node and all that. And here are some different stages of the oocyte that we're going to look into. So the ovarian cycle, it begins with oogenesis. Okay, oogenesis is it makes an oocyte. So the ovarian cycle has 2 stages. Okay, one of them is called the oogenesis, development of the gametes, and then there's something called the follicular genesis, and it will develop the follicles. Okay, so follow me here. Okay, so the before birth, okay, all this is made. Okay, about 4 million. Okay, 4 million is made. Yeah, right there. Okay, during prenatal development of a female, oogenesis divide by mitosis reproduce more than 4 million. But unlike male, the oogenia develop into primary oocyte. Okay, and it will start meiosis 1. At birth, millions left, no stem cell, and at puberty, by puberty, only about 400,000 is left. Okay, but how many do you need? You just need 1 per baby. Okay, 1 per baby. So if you do the calculation, pretty much about 10,000 of them die each month, and we don't know why. Okay, so here's the meiosis. It stops at prophase 1, then after puberty, it'll resume. Okay, then it will stop at metaphase 2. Okay, at the secondary oocyte. Then this is before the sperm gets in and fertilize the egg. Once the sperm penetrate, then the oocyte meiosis will be complete. Okay, so That's how the female ovarian cycle works. Then the oocyte will develop in a follicle. Ovulation, releases of the oocyte and some follicular cells from the ovary, transition from puberty to reproductive maturity. After this, once every 28 days, you should get a period. It's because of the surge of luteinizing hormone, which caused the primary oocyte to become secondary oocyte. So I think we have a graph somewhere in the back later on in the slides with the when the surge of the luteinizing hormone, that's when the egg is released, okay, producing one large cells, okay. Secondary oocyte will not finish meiosis 2 unless it's fertilized, and we're talking about here, okay. So again, going back to here, surging of that, then once the egg is fertilized, okay, it becomes an ovum, if it's fertilized, okay. The sperm does not contribute anything except the DNA, Follicular genesis. Okay, here's the follicle maturation. So let's look at the growth and follicular genesis. Growth and development leads to ovulation every 28 days, and death of many others. Okay, there are 4 follicular stages. We're going to look into here. Oocyte remains a primary oocyte until right before ovulation. So here is the first stage. It's called primordial. Primordial is mainly just flat supporting cells, okay, surrounding the oocyte, okay, just flat. Then it becomes the primary follicle, okay. The cell now becomes thicker, okay. This is after puberty, okay. It becomes more round. At the secondary follicle, more cells is added. You can see here, these are called theca cells. Okay, they actually helps produce estrogen. Okay, they help produce estrogen, and they are surrounded in this primary stage. They are surrounded by something called a zona pellucida. And you can see here, zona pellucida. Okay, and here's the theca cells on the outside, which produces estrogen, okay. After the secondary follicle, we're following this to the tertiary follicle, okay. So step number 4 is tertiary, okay. Remember, the first one is just primordial before the primary, and then secondary, and then tertiary. Then at the tertiary is the more fluid is secreted between the granulosa, okay. Here is the ovulation